The project goal is to work on systems with limited hardware resources while using the modern tools and joining communities that have worked with these systems to gain knowledge about techniques to develop classic games using high-level languages. The project is divided into 4 parts in which we develop 4 different games with different features and challenges that would help us understand how games were made for these consoles, with the final goal being the 4th game, where we will have to apply all the things we learned from the 3 previous games to make a more complete game. For our project, we were required to work with a system from the 16-bit generation or earlier, so basically we could work with anything before the Super Nintendo. And we decided to work with the Game Boy, which is an 8-bit handheld console developed by Nintendo, and has an 8-bit CPU and has a color support of 2 bits, which are 4 shades of light to dark olive green. And despite being an old console, we found some communities dedicated to developing homebrew Game Boy games, which are mostly for the Game Boy Color, but we thought that there will be a lot of resources for us to learn about it, and that's why we went with the Game Boy. To code our games, we use the Game Boy Developers Kit, GBDK, which is a set of tools that grants us the ability to develop our games in C. This set of libraries allowed us to compile our C code into 8-bit assembly code, generating .gb files that can be used on a real Game Boy or with an emulator like Virtual Game Boy. We also use Visual Studio Code as our IDE, and we use BGB64, which is an emulator for the Game Boy that allowed us to see the VRAM, the memory banks, and other useful information when debugging the games. And to design the sprites and the maps, we use a tile designer and a map builder. So the tile designer is a program that we use to design the tiles in 8x8, and a map builder allowed us to use the tiles in a canvas to draw the backgrounds for our Game Boy games. And the major reason we use this to build our maps instead of using other methods is that once we build the maps and the tiles, we have the option to export the design directly to assembly source and to GPDK C source, and it will provide us the tiles and the maps as arrays of hexadecimal data that the GBDK header file can interpret. For the first game, the requirements were a tile screen and a simple text game. This could be a number guessing game or something simple like that. And at the beginning, we wanted to do a cave adventure game where the player could choose to go right or left. But we opted for a true and false game since we thought only going left or right without any information will be stressful for the player when losing. So the game will start with this splash screen of the girl looking at a cave, and we did this title screen in GIMP, and after that we have to resize it, convert it to grayscale, and then we ran an index color conversion with a maximum of 4 colors because the Game Boy only has 2 bits of color support. And after that we got this image. But to actually include it in our game, we used a Game Boy PNG converter that converts it takes the PNG and outputs 2 arrays. One with the tiles that are used in the background and another one with the map. So to display it, we first have to load the tiles in the VRAM of the Game Boy, and then with the map array, we show the tiles in the desired order, as shown here. And after pressing the start button, we print the instructions in the screen, and the user has to choose true or false by pressing A or B. The questions pool is selected randomly from a questions array. That way the player gets a different experience every time he plays the game. And some of the issues we had is that while using the GBDK header files, we could not use some of the C built-in libraries like time.h, and therefore we had to get the seed for the random generator by measuring how long the user holds the start button after the title screen. And after the player either wins or loses by answering a question wrong, a screen with the player's score is shown.
Thank you, Jesus. So for our second game, we were required to make a fixed screen game with at least one character sprite, one independently moving sprite, and for the game to have some sound. An example of these requirements that we can think of is like a game like Pac-Man, the picture on the left, and or a game like Space Invaders as we see on the screen on the right. Both games have one controlled sprite that move around the fixed screen and interact with other independently moving sprites. So for our game called Spook a Coin, as you see on the picture on the left, bottom left, it meets all these requirements. The purpose and goal of the game is to dodge falling ghosts and at the same time collect as many coins without getting hit. The player only has one life and the game has up to 5 levels in which the difficulty gets more and more challenging and the speed of the ghost gets faster as the player collects more coins. We also added a score and level counter to the screen and a game results background when the player loses, as you see on the right. And let's move on to the gameplay. So in the gameplay, there's 3 different sounds. Uh, one when you collect a coin, one when you level up, and one when you lose the game. Moving on to game 3, where we were required to make a side-scrolling game. A great example of a side-scrolling game is Super Mario Land. We posted a small little picture for reference, but going back to our game, which we named Ghost Hunter, as you see on the bottom left picture, the objective to Ghost Hunter was that there was incoming ghosts that you would have to dodge and either shoot or dodge and collect as many coins as possible without being touched by the ghosts. The theme of the game is that there's a haunted house that this ghost hunter goes through and kills as many ghosts as possible while collecting coins and dodging enemies. A feature we also added was that if the player misses a coin, he will lose a point. So this gives the player an incentive to collect the coins and not let them just pass by and take more risks because the coins and ghosts touch often and it'll make the game way harder to reach a higher point level. So for the start screen, we also used GIMP to make this picture, and we converted this picture to a Game Boy file .c file. So onto the gameplay of our third game. So here we only have 3 sounds when the player dies, when the bullet comes out of his gun, and when he collects a coin. And this brings us to our last game, where we used all our previous knowledge from our other games and applied it to this one. So for this game, we decided to go with a maze game. As you can see from the title, Maze Run on the left picture, we came up with this idea to make a maze game where the player must find their way to the ladder while at the same time avoiding the ghost touching you and a wolf seeing you. There are 4 levels currently, and you're only able to access the ladder on the top to move on to the next level until you collect the key in that room. So in the picture on the right, you see the key on the left side and the ladder on the top. So you have to make it through the whole room without being touched or seen and make it safely to the ladder to get to level 2. The difference between the wolves and ghosts is that if the wolf sees you directly in his path, he will attack and the player will die. All enemy sprites move in a fixed pattern using the AI we previously used for Game 3. These levels get more difficult as the game progresses, and in the end if the player wins, a message is shared stating that they made it safely out the maze. Another feature we added to this game was our start menu, which has one sprite that is controlled to either select start or select story. We also added a character select with up to 3 different characters the player is able to select and choose.
The first thing we worked on for this game was the background collisions. So to make things easier, we made it so that the characters will only move 8 pixels, and this way it can only move from tile to tile. This trick is used in a lot of classic adventure games like Pokemon, where every character can only move, it can only be in tiles and not between them. Then we made a function that will convert the X and Y location to the corresponding tile in the background, and after that we will compare that tile in the background array to see if it was an empty space. Then we called that function in every input function to check if the tile where the player wanted to move was an empty space before actually moving the player. We also use this method to see when the player will get to the key or reach the stairs for the next level. So this method allowed us to build the maps and don't have to worry about the collision information because those functions were usable for all the maps we were working with. Then we coded the movement of all the enemies, and at the beginning we wanted to have every character be able to see you to make the player hide to avoid being seen. But after we coded all the enemies, we noticed that coding that type of collision for all the enemies will take a lot of memory from the bank, and that's why we made it so that the player will only have to avoid being hit by the ghosts and hide from one wolf in each level. The memory constraints of the Game Boy were more noticeable in this game, as I mentioned earlier, because of all the enemies. And we wanted to add more sounds and music like in the previous games, but in the last weeks we noticed that we were running out of memory, and we tried a lot of methods like using different banks in the ROM or setting a lot of variables to be constant to free some of the space, but at the end we were not able to squeeze in more levels and details in our final game.